thing. Okay, number 8. This is the hardest one in the homework. Here we go. You know, step 1 is to graph at desmos.com, get any clear zeros. Okay, I've got the graph for us here, and you can see some clear zeros. Actually, there's a couple of them, huh? So this is 1, 2, 3, 4, 5. So right there at 3. And then right here, this one's at -1, isn't it? So we have 2 clear zeros on the graph. X equals -1 and x equals 3. Okay, x equals -1. Here, let me put it over here. X equals -1, x equals 3. And then notice what they say. They say 6i is a 0. So that means x equals 6i is a 0. And here's a special rule that you need to know about. Imaginary, which are also called complex. An imaginary number, a complex number, an imaginary number, that's a complex number has an imaginary and a real part to it. So this is really 0 plus 6i. Its real part is just 0. Its imaginary part is 6. That's a complex number. Complex meaning it's not simple. It's made out of 2 things, a real number 0 and an imaginary number 6i. So a complex number or imaginary, it's pretty much the same thing. Imaginary complex 0, if you have one like we have one right there, always the conjugate is also a 0. Now, what do I mean by conjugate? Opposite sign on the imaginary, in the middle. In the middle on the imaginary part. Opposite sign, sorry, I'm getting a little scribbly there. Opposite sign, let's say, opposite sign in the middle on the imaginary part. So if we have 0 plus 6i, that's really how you would write out. I mean, you don't really need the 0. Then the conjugate, that's the one we have right here, 6i, which is the same as 0 plus 6i. The conjugate, which means, conjugate always means opposite side in the middle. When we do that in math, we use that for various things. Conjugate means opposite sign in the middle. That'd be 0 minus 6i. You just change the sign in the middle. In other words, you change the sign on the imaginary part. So in other words, it's really just minus 6i. The 0 is not doing anything. That's also got to be a 0 automatically. That's what we're saying. Whenever you have an imaginary 0, its conjugate will also be a 0. So if 6i is one of our zeros, which they told us it is, then minus 6i, the conjugate, the opposite sign in the middle on the imaginary part, is also a 0. So we really know that x is minus 6i is a 0, as well as x equals regular 6i, and x equals -1 and positive 3. We can see those from the graph. So we already have 4 of the zeros. And this is 5th degree, so there's only one more to go. The degree tells you how many zeros, right? There's only one more to go. So we just need to find that last one, but that's easier said than done. So I'm going to go to a fresh screen where we have a little room to work, taking the information we have. So now on number 8, we have the function p of x equals 3x to the 5th minus 7x to the 4th plus 101x cubed minus 249x squared minus 252x plus 108. It's a big function. And we know that the zeros, we know 4 of the zeros already. What are they? X equals, from the graph, -1. X equals 3. X equals 3. I think we put 3 first. It doesn't matter. Whatever order doesn't matter. X is 3, X is -1, and X is 6i, and X is minus 6i. We know those are all zeros. We just have one more to go. So how are we going to find that one more? Well, basically on this one, step 1 is the graph to get the obvious zeros. Step 2 is the divide, right? This is all step 1, get the clear zeros. They gave us 2 clear zeros from the graph. They gave us this 0 by just telling us 6i was a 0, and then we figured out the conjugate. Whenever you have imaginary numbers, then the conjugate, the opposite sign in the middle on the imaginary part, is also a 0. So now we can divide. Divide by what? All of them one at a time. So here we go. Let's start with, we're going to take these coefficients. 3, -7, 101, -249. In fact, I probably better space these out. We're going to need a little bit of space here. So, 3, and then I'm going to go way over here. -7, then way over here, 101. Way over here, -249. Maybe I'm going a little too far. All right, 101 -249 -252, 108. Okay, so let's bring down the 3, and what are we dividing by now? We're dividing this one by the by this 3. We'll start with the first one. So this one right here, the 3. All right, so here we go. You know how this works. 3 times 3 is 9. Add them up. 2. And 3 times 2 is 6. Add them up. 107. And 3 times 107, use your calculator, 321. Subtract those in your calculator, 72. And 3 times 72 is 216. Get minus 36. You know what the last step's going to do. I'll do it anyway, but you know it's always going to end up being 0, huh? 3 times minus 36, minus 108, 0. And let's put our wall there. We're going to see that wall creep over. That's the remainder, which means we did everything perfect, and x equals 3 really goes in. Okay, now we have a bunch of stuff left. So we have to divide again. Do you realize we gotta do this again? Let me get these out of the way, and we're gonna long divide here, and here we go. We're gonna actually do it again. This is round 2 now, and now we're gonna divide by the next number, which is -1. So now I'll put -1 there and do it again. So we take what's left over and we divide again. We just keep dividing. So bring down the 3, and here we go. -1 times 3 is -3. Add them up, -1. And then -1 times -1 is +1. Add them up, 108. And -1 times 108 is -108. Add them up on your calculator, -36. And the last step, -1 times -36 is plus 36. Add them up. No surprise, 0 remainder for that one. See how it's getting smaller, our answer, the remainder is moving over? All right, now, so we've done those two. We're down to this point. We just keep dividing. So whenever we have a 0, we can divide by that 0 and get what remains. So now we're going to go to the next one, which is an imaginary 0. We haven't done that before. So I'm going to divide by that imaginary 0, 6i. That's the next one, right? 6i. So here we go. Bring down the 3. You can do it with imaginary zeros just like you do it with everything else. Just got to be careful. 6i times 3. What's 6i times 3? Well, 18i. And then when you combine this and this, they can't combine. One's a real number, the other's imaginary. So just bring them down, 18i minus 1. You can't, they can't make 17 or something because they're different. They're unlike terms. One's an 18i and the other's just a regular negative 1. Okay, so then do your next step. 6i times, now what's going to happen? 6i times 18i is, what's that, 108i squared minus 6i. Do you see what happened there? The 6i multiplied the 18i. 6 times 18 is 108, and I times I is I squared, and then the 6i hit the minus 1 to be minus 6i. It distributed. The 6i distributed to both the 18i and the minus 1. Now, what do you do with I squared? Remember that I squared is negative 1. That's maybe a rusty point for you. So it comes down like this. Yeah, I squared is negative 1. See, we leave regular I. See how this 6i, that's just a normal I. We'll leave that. We don't mess with that. I is just I. But the I squared right here is negative 1. We don't leave I squareds hanging around. I squared is negative 1. So whenever we see I squared, let me write it somewhere over here. I squared is negative 1. We always replace I squared as negative 1 because it is negative 1. We never leave I squared hanging around. So this becomes negative 108 minus 6i. That's what goes right here. Negative 108 minus 6i. And then we add this with this, and you see how the 108s cancel, and you just get minus 6i. And then let's do our last step here. 6i times minus 6i is minus 36i squared. Minus 36i squared, right? Because 6i times minus 6i, 6 times minus 6 is minus 36. I times I is I squared. And again, what do we do with I squared? We leave regular i's, but I squareds, we replace I squareds as negative 1. So that'll be negative 1, which is positive 36. This is going to become positive 36. Do you see that? Because it was 36i squared, and I squared is negative 1, and 36 times negative 1, or negative 36 times negative 1 is positive 36. All right, and so what does that make? No big surprise. 0 remainder. That's perfect. We got to get that. 0 remainder. Let me get rid of all this stuff. So we got another 0 remainder, which means that went in perfect. No surprise. They told us it was a 0, that it would go in perfectly. So, okay. So now we have one more 0 we still haven't used. Right? We used 3. Let me get rid of this stuff here. That was 3. We used the 0, 3, the negative 1, the 6i. One more to go. The minus 6i. The minus 6i. So now I'll do the minus 6i, the last 0. This will be it. Bring down the 3. Minus 6i times 3 is minus 18i. Add these guys up. 18i minus 1 and minus 18i. These cancel, it's just minus 1. And then minus 6i times minus 1 is plus 6i. Minus 6i and plus 6i, no surprise. 0 remainder again. Okay. After all that dividing, we were given 4 zeros. This is very different, right? Normally we only have 1 0 to divide by. This time we had the 2 zeros from the graph. You know, the 3 and the negative 1. We divided by 3 and negative 1. And then they told us 6i was a 0, so then his conjugate, negative 6i, is also a 0. Divided by all those, just kept dividing. And what are we left with? We're left with this. So now, y equals, this is going to be 3x minus 1. And then for each of these guys, remember we do opposite, so it's going to be x minus 3, and then opposite, x plus 1, and then opposite, x minus 6i, and then opposite, x plus 6i. There we go. There's the factorization that they wanted on this problem. That one was a lot of work.